everyone, welcome back to my channel. I hope you all must be doing well. In this video, we are going to discuss about temperature sensors in detail. Temperature sensors play a crucial role in collecting data for smart and automated systems. These sensors enable devices to monitor temperature changes and share this data over the internet, allowing real-time analysis and decision making. IoT temperature sensors are integral to various applications including smart homes, industrial automation, healthcare, agriculture, environmental monitoring, etc. Now let's discuss the applications. First is smart homes. It is used in climate control in smart homes, that is for IoT enabled temperature sensors can help optimize HVAC systems for energy efficient heating and cooling based on real time temperature readings. Second, in smart homes it is used for safety in smoke and fire detectors to trigger alarms and notifications when temperature thresholds are surpassed. And third application in smart homes is smart appliances, integration in devices like refrigerators, ovens, etc. Okay, now second application is industrial automation, in that predictive maintenance. Firstly, monitoring machinery and equipment temperatures to predict failures or schedules maintenance before issues arise. Now second in that is process monitoring. It ensures consistent temperature conditions in manufacturing processes to maintain product quality. And in supply management too, temperature sensors in logistics to monitor and control conditions during the transport of temperature sensitive goods. Now the third application in that is healthcare. It is used for patient monitoring and pharmaceutical storage. Okay. Now the assist in regulating grid performance and detecting potential overheating or failures. And even in renewable energy systems, that is for monitoring the temperature of solar panels and wind turbines to optimize performance and prevent damage. Now the sixth application is smart cities. It is for in that environmental monitoring and building management systems, that is for integrated in commercial buildings for efficient temperature control, reducing energy consumption and enhancing comfort. Now the seventh application is food and beverage industries, that is for cold storage monitoring and quality control. That is in quality control, maintaining optimal temperatures for food preparation and safety in food service establishments. Now the eighth application is automotive and transportation, in that it is for vehicle monitoring, that is sensors can detect engine temperature and cabin temperature to provide feedback for performance and passenger comforts, and also for cargo temperature monitoring. Now the ninth application is research and development. It is for scientific experiments, that is IoT temperature sensors are used in laboratories for precise monitoring of temperature sensitive experiments and also for data collection for analytics, that is large scale temperature data collection for various research applications like climate modeling and product testing. Now the 10th is disaster management, that is in wildfire detection and weather monitoring systems. Now let's discuss few of the advantages too. The first is real-time monitoring. Temperature sensors enable continuous and real-time monitoring of environmental conditions, which is essential for responsive IoT applications like climate control and supply chain management. Second is automation and control. They can trigger automated actions based on temperature readings like turning on AC or sending alerts in case of overheating. Third is energy efficiency. IoT systems that utilize temperature sensors can optimize energy usage by dynamically adjusting heating and cooling based on current needs. Now, the fourth advantage is improved safety. In industrial settings, temperature sensors can detect potential issues like overheating machinery, helping to prevent equipment damage and reduce the risk of fire hazards. Now, the fifth advantage is data collection and analysis. Sensors provide valuable data that can be used for predictive analysis and trend analysis. Now, the sixth application is versatile applications. Temperature sensors can be used in a wide range of environments and industries from healthcare to agriculture. Now let's discuss few of its disadvantages. First is connectivity issues. IoT devices rely on stable internet connectivity to transmit data. If there is a network failure, real-time monitoring and remote access could be compromised. The second disadvantage is that security and privacy concern, like all connected devices, are vulnerable to cyber attacks. Unauthorized access to sensor data could lead to privacy issues with environmental control. The other disadvantage is power consumption. Continuous operation of temperature sensors, especially in remote or battery operated IoT devices, can lead to significant power consumption requiring regular maintenance or energy efficient solution. The fourth disadvantage is calibration and accuracy. Sensors may require regular calibration to maintain accuracy. Incorrect readings can lead to improper automation responses affecting system reliability. Okay, now the fifth is environmental limitation. Some temperature sensors may not function effectively in extreme conditions like very high or very low, which can limit their applicability in certain scenarios. Okay. Now the sixth disadvantage is cost of implementation. Deploying a large number of temperature sensors along with the necessary networking infrastructure and maintenance can be costly, especially for large scale projects. And the last disadvantage is integration challenges with existing IoT ecosystems and ensuring interoperability with other devices. It can be complex and may require custom solutions. Let's discuss factors to consider for compatibility of temperature sensors. The compatibility of temperature sensors depends on various factors including the type of sensors, its intended application, and the system it needs to interface with. The following are the key compatibility considerations for temperature sensors. Okay, the first is interface and communication. Many temperature sensors provide analog voltage or current output which needs to be converted to digital signals using an analog to digital converter. Sensors like semiconductor temperature sensors can provide digital data via communication protocols, making them compatible with modern microcontrollers and processors. Some advanced sensors have proprietary interfaces that require specific hardware or software support for full compatibility. Okay, the second factor is power requirements. Certain temperature sensors, especially semiconductor based ones, are designed for low power operation, making them suitable for battery powered devices. Okay, and some sensors like IR sensors, which advanced optics may require more power and therefore need to be paired with systems that can supply adequate power. Okay. The third factor is environmental compatibility. Ensure the sensor is compatible with the operating temperature range of your application. Okay. And in industrial or harsh environments, compatibility with protective enclosures or sensors housings is important to prevent damage from exposure to moisture, dust or chemicals. Okay. And the fourth factor is signal conditioning. Some sensors like thermocouples and RTDs require signal conditioning, that is amplification or filtering, etc. for accurate readings which must be compatible with the existing system. Okay. Thermocouples require cold junction compensation to provide accurate temperature readings, so compatibility with the system's compensation method is necessary. The fifth factor is calibration and accuracy requirements. RTDs and certain thermostats or thermo, thermosistors may require periodic calibration to maintain accuracy, and the system they integrate with must support this process. Okay. Different applications. demand varying levels of precision. And the sixth factor is the software compatibility. Sensors that communicate digitally may need compatible sensors or libraries for seamless integration with microcontrollers or computers or IoT platforms. Ensure that the data output format from the sensor matches the input requirements of the data processing system. Okay, now here comes to an end of this video. If you have any doubts, do let me know in the comment section. Thank you so much.